Hi everyone, I'm Miss Peel. I'm a science teacher here at Newman. We're very disappointed we didn't get to have you all come in for a taster day into the science department here at Newman this year. So what we thought we'd do instead is we would show you what we would have been doing in school and you can have a little go at it at home hopefully. So we would be saying welcome to science. We are very excited for you to start in year 7. We've got lots and lots planned for you. It's going to be a really great year of science. But what we're going to think about today is one of the topics we look at in year 7, which is all to do with substances that we call acids and alkalis. Okay? So, substances can be described as acid or alkali. Acids tend to be sour. You might know that from eating things like, you've ever eaten a lemon, it tastes very sour, that's because of the acid inside there. Alkalis tend to be more soapy, so obviously we don't tend to eat them because why would you want to eat soap? But things like soaps and bleaches tend to be more on the alkali scale of things. So, as I mentioned a scale there, we have got a whole scale of starting at acid all the way through to alkali. Okay? And you'll notice here in the middle we have something called neutral. That's where a substance isn't an acid or an alkali, it's just in the middle. Now you'll see there are some colours here on this scale. So what those apply to is something that we call indicators. Okay? So we can't just taste things to check whether they're sour or soapy in a science lab. Okay, I'm not just going to start tasting some acid because that wouldn't be safe. So what we do instead is we have a special set of chemicals that we call indicators. And we put those into our substances and they'll change colour based on whether we've got an acid, an alkali or something neutral. So I'm just going to prove to you that I'm not lying to you about indicators. So we've got here some hydrochloric acid. This is an acid you'll use all the way through school, from starting in year 7 all the way through to year 11 in science. Safety first. So, if we pour a bit into a beaker, which is another piece of equipment you'll become very familiar with during your time here at Newman, I'll then put in something that we call universal indicator. This is the indicator we use most often in science labs. You'll notice it starts off this sort of murky green colour, and as I put it into the acid, we end up with a nice reddy pink colour. So that tells me that I've got an acid. If I go back to that scale, you can see down here the strong acids, we call them, tend to go this red or orange colour. I'm then going to try another chemical that we use all the time in science here. This one's called sodium hydroxide. A little bit less clear from the name what it is. The other one told us it was an acid in its name. This one, it could be anything. So we'll test it, see what sort of substance we've got here. A little bit in a beaker. Bit of universal indicator again. So you can see again, starting that murky green colour. And now we've got a dark blue. If I hold it against the white, you should be able to see a really dark blue colour in there. Okay? So if I look at my scale here, the universal indicator, it tells me that is an alkali. So I know now that this is an alkali. We've got one last thing to test with our universal indicator, water. Okay? This says distilled water. That basically means it's really, really pure. It's not just like the water that comes out of the taps, it's just water in here, it's really pure. So, we'll pop a bit of that into a beaker. There it is. As you can see, it's another clear, colourless liquid. No way of knowing just by looking at it whether it's an acid or an alkali. But if we put in our indicator Give it a swirl. We've ended up with a sort of, well, yellowy green. I would have expected it to have been a bit greener than that, but this is science, you know, things often come out not quite where you expect. We'd expect it to be neutral, okay? This one might be slightly acidic, who knows why. So there, you can see, if I put those all next to each other, three colourless liquids with the same indicator placed in them have gone three completely different colours. Now, this isn't something I would imagine most of you have got lying around at home. I'd be surprised if you did. What we're going to do today is we're going to make some of our own indicator. We're going to use this ingredient. You might have seen it before, you might have eaten it in winter or at Christmas, purple cabbage, red cabbage. So, what you need to do, and this is a bit where you need to be careful, you'll need to have an adult to supervise you, because we're using a sharp knife. We're going to cut a little bit of red cabbage up. Okay. We're going to place it, I've got a beaker, again, probably not something you've got lying around at home, but just a cup or a mug, anything's fine. Pop some of my cut up red cabbage in there and pour over some just boiled water. Again, something I suggest making sure that you are supervised by an adult for, okay, because we don't want anyone getting burnt. So carefully pour over the boiling water. And what that's going to do is it's going to take the pigment, which is a scientific name for the sort of colour, it's going to take the pigment out of the cabbage. And you can probably see already, again if I hold it against the white, that water's started to go a sort of bluey red colour. I've got one that's been sitting on the side for about 5 or 10 minutes. That's probably how long you want to leave it. And we are going to take off a bit of the liquid, again be careful because it's still going to be hot, into some beakers. Okay. Clear up a bit of this mess. Hopefully you're not making quite as much mess as I have done at home. So, we can see that we're starting now, instead of the universal indicator, which started a green colour, we've got our purple cabbage indicator is starting a blue colour, bluey lilac maybe, okay? So clearly we might have some different colours going on here in our indicator. We're going to just test now. Again, this is not stuff you'll have at home, the hydrochloric acid and the sodium hydroxide. But we'll just test what colour it would go. So with an alkali, you can see it's gone green. Okay, so on this scale, the alkali has made the indicator turn green. We'll try again with our water, which will show us what neutral, neither acidic nor alkali, looks like. And it stayed the same colour. That's usually what we expect with an indicator. It just stays the same colour in neutral. So I'd describe that as blue. Obviously colours, you know, everyone's got a different opinion of what a colour would be called, but I'd call that blue. And then I'm going to check it with acid. I'm going to put in some of my hydrochloric acid. Okay, and again, like magic, it has changed colour. We've got a reddy pink colour for the acid. Okay, lots of science is to do with things changing colour, reactions happening. So what you're going to do at home is you're going to go around your house, again with an adult supervision to make sure you're not picking up anything too nasty, but you're going to pick up a few different liquids around the house. You might try bleach, This is something you want to be really careful with. Make sure that you never use the bleach without an adult supervising you. You might try some soap or some washing up liquid. You might have some vinegar in your kitchen cupboard. You might try water from your tap. You might test milk, any liquid that you can find around your house and that an adult has given you permission to use. You can try using your indicator to check whether it's an acid, an alkali, or a neutral substance. It was really nice to talk to you today. It's a shame that I haven't got you all here with me, but hopefully by September we'll all be in the lab and we'll be able to start cracking on with your Year 7 science.